We discussed that artificial intelligence is all about artificially building the intelligence which is similar to human brain. Biological intelligence or biological system, people try to mimic that and come up with something called as artificial system, right? And that is where we have discussed about a human brain, and we discussed about a few things here. Then we discussed that given an input within a neural network, there will be multiple layers. Each layer would try to extract features from the image. Those features could be anything. We just cannot make out on what those features would be. And finally, you get an output, right? This is called as image classification problem. Given an image, we are trying to classify on what that is all about, right? So each intermediate layer provides or tries to extract some meaningful information from the image which is uploaded. You might have vision, speech, or textual data. From that, either you might want to manually extract the data, or you might want to extract the data using neural network. Okay, so I was saying that we started off with this, and we understood that artificial intelligence is all about mimicking your human brain, right? And human brain has all these components. If an image is provided as an input to a neural network, then it will start extracting a lot of features. But what feature does it exactly try to extract? This is not known to us. It extracts some information. Okay. And then finally, it classifies on whether this image which is uploaded is a car or is it a bus or what it is exactly. There are a lot of layers, right? Each layer will try to extract some information. Either you might want to manually extract the features and use those features for some kind of a prediction, or you might want to use deep learning, which will automatically extract the features. But the flip side of using deep learning is that you would not know on what feature you're extracting. But when you manually try to extract the features, you will exactly know on what feature you're trying to extract. Your all the models such as linear models, support vector machine, and a bunch of other techniques, machine learning algorithms are available. These are called as shallow models, and you have one deep model. Deep model means it is going to extract a lot of interesting features from the image. Is deep learning a holy grail? Absolutely no. It would not help you solve all the issues, right? There are a lot of challenges associated with using deep learning. However, research is going on to solve those kind of problems as well. All right, that aside, now let's understand about what this neural network is all about. Of course, within neural network or for using deep learning, we mainly use something called as neural network. Okay, we use mainly neural network. Whatever you're seeing here is called as a neuron. Neuron will take the inputs and give an output. But these inputs are weighted inputs. That means there are weights associated with each and every input. Let's take this example, the same thing. This is a neuron. Within a neuron, there will be two things. Within a neuron, there'll be two things. Within a neuron, you'll have one thing which is called as summation and another thing which is called as activation. Very important. This is all that neural network is all about, understanding this simple diagram, right? Dendrites come from your biological neuron, right? This is a biological neuron which has dendrites. Dendrites are nothing but, think about these as inputs, connections to the inputs. These are dendrites. This is called as cell body or soma, right? A neuron is called as cell body or soma, right? And the thing which gives you the output is called as axon. That's it. So this is a biological term. This is a biological term and biological term. So we want to come up with a neuron which is similar to biological neuron. That's it. That has motivated this field of deep learning. And deep learning is extensively used in building artificial intelligence applications. Okay. In this session, do we have anyone who is not part of AI deep learning training, who is just continuing, or is everyone? Lakshmi, are you there, and are you able to hear me? If you're able to hear me, then just confirm on whether everyone here is for deep learning training or not. Okay. Each and every input is connected to the neuron, right? And each of these inputs will have an associated weight. These weights are randomly assigned for the first time. They are randomly assigned. Randomly, algorithm picks some random numbers and says that, hey, these are the weights. And also, there is a new input and a new weight which gets added, which will not be part of your data. So in your historical data, you know for a fact that you'll have an output and you'll have various inputs. So each of these inputs go in as input to the neuron. And initially these weights are randomly assigned. Alongside, there is another weight and input which gets added, which is nothing but bias. This is called as bias. And the input to this bias, or this input, will always be 1, and it has a weight which is given using B, which is bias. Imagine that this is also another weight which gets randomly assigned. But the only thing is the input will always be 1. So you'll have another input, all the values will be 1. That's it. Okay. Now what happens here? Summation. It's a sum product, right? This aggregation function or integration function, what does it do? It simply does a sum product, which is the most widely used. Sum product means you will say b into 1 plus w1 into x1 plus w2 into x2, x3 plus so on and so forth, w4, x4 plus so on and so forth. When you add these, you'd get a value here, some intermediate value. This some intermediate value, or the output that you get, you pass it through another thing, another function called as activation function. So you pass this through something called as activation function, which finally then gives you the output. You can reduce this. B into 1 will always be B plus, you can say WTX. That means you're considering all these weights, which is equal to Y. That is what is given here. Any doubts on this slide? This is extremely important. If you understand this, you will understand everything else. All right. So now, once you get the output, for the first time, this bias and the weights are randomly assigned, right? They're randomly assigned. If they're randomly assigned, how would it give you the accurate output? Whatever value comes to your mind, you're just assigning that value. That means the output that you're going to get will not be of good quality, obviously, because you're randomly choosing some value. Hence, though you initially assign the weights randomly, you will have to keep updating the weights. And you're going to stop at a specific point where you feel that now the weights are concrete. Until and unless you feel that now the weights are concrete, I mean, the weights are the right weights, your algorithm should continue updating your weights. So what happens is the moment you get an output here, that's called as the predicted output. But in your data set, for every output, you'll have a bunch of inputs. Right? This is the historical data which is provided to you already. And you got the predicted value. But here you have the actual values. Hey, for these bunch of inputs, what would be my actual output? That's your historical data. When I supply those inputs to the model, then the model is giving me some y, which is predicted y. Now, is this predicted value and the actual value in sync or not? If they are not in sync, then you'll get some error value. Error is nothing but predicted value minus actual value. So you get some error value. That some error, bearing that in mind, your algorithm will move backwards. So it has moved in the forward direction to predict your y. That's called as a forward pass. Then in the backward pass, while it is doing this back propagation, it tries to update the weights such that your error is reduced, such that your predicted value and actual value is closer to each other. Right? So the technique which is used to update the weights is called as back propagation. Okay, so using this back propagation technique, the weights are updated. This is the basic thing which, I mean, of course, this is biological neuron. It's not a biological class, so I'll just quickly skip this. Okay, so in the initial days, right, there was something called as MP neuron, a McCulloch-Pitts neuron. That's how it all started. Then it moved on and it got refined further. Then Rosen black perceptron has come into picture, which has used something called as Hebbian learning, right? And what are the drawbacks of Hebbian learning? Then Windroff has come up with another learning algorithm, right? All that is aside, let's now actually understand about a basic neural network, which is called as perceptron. Let's understand about something called as perceptron algorithm. What happens in this algorithm is, once again, the same logic here holds good. You'll have a bunch of inputs and you'll have output. Finally, you'll get an output here. So these are the inputs. Okay, so you have x1, x2, x3. They'll have weights associated. Then those weights go into this neuron, wherein you'll have two things, integration and activation function. Finally, you get an output. Okay. Initially, how are the weights assigned? This is a symbol for vector. Vector is collection of all the weights. W1, W2, W3, W4, in that way all the weights and the bias. All put together, you're representing that as W0. Then this is a formula to update your weights. In the previous session, we discussed about something called as learning rate or eta value, which usually ranges from 0 to 1. And when people choose it, they choose it very less. I mean, this is a hyperparameter which you can change based on your own logic.